wanted to quickly go over how to do several of these problems on tonight's homework. First of all, I'm doing this transformation by exponentiating. On the left we have y hat. On the right I have 10 to the 6 times 10 to the 4x. This is an exponential equation. The one on the right I've started the same way. It's almost the same equation except for the x has been transformed as well using the logarithm. So I've got on the left y hat 10 to the 6 times 10 to the 4 log x, which is 10 to the 6 times 10 to the log base 10 of x to the 4th, and finally 10 to the 6 times x to the 4th, and this is a power equation. I want to talk about the carpeting a room data, which I've already entered into the calculator, and I have performed the regression equation. As you can see, the residual plot let me make sure that I have this cleared. The residual plot does show that we start above. We have positive residuals, 3 negatives followed by a positive, suggesting that we can probably find something that's better. I've also already taken the logarithm of the x and y variables. I'm going to calculate a linear regression for x with the log of y, which I have those in list 4. I'll put that in y1. And I'm going to take a look at those residuals again. Not terribly bad, but this time we start below, we go above, below, above. And I just want to see, at this point, I have with this would be the exponential model. I'm going to go back to the home screen and check what, let's do that instead. Let's take a look at that again and look at what the r and r squared values are. R squared is 0.975, r is 0.988, and I'm going to try one more thing, and that's going to be the linear regression on the log of the x values, which I have in list 3, as well as the log of the y values. So 0.983 and 0.992, the r and r squared values are slightly, just slightly improved. So let's take a look at the residual values. Does not look much different than what we had before. Probably should have traced to see actually how large those values are. But if we think about this idea that we're carpeting a room, and it's also suggests here that we're talking about area in square feet. It seems to me that a power model seems most appropriate. I'm going to record the regression equation that we had there, which is log of y hat is negative 0.109 plus 2.09. Remember, this is the log of x. And I'm going to undo that by exponentiating. Y hat is 10 to the negative 0.109. And following what we did above, then this would be x to the 2.09 power, which is a squared power We notice that this is in square feet, and that seems reasonable. What I want to show you yet tonight is how we would estimate the cost of carpeting a room that's 12.5 feet in length. So I've got my regression equation in Y1, and I have actually transformed the x variable as well. So where I have x, I'm going to change that to log of x. And then I'm going to exponentiate, just as we did with the exponential equations. Again, I'd like to just turn this off so it doesn't get in the way. I need to go back to my original data, which is in list 1, list 2. So here's the exponential curve. And I'm going to go to second trace, which is calculate for a value of 12.5. And you can't see that very good, but my predicted number of square feet is 152.7. So y hat at 12.5 is 152.7 at a cost of $3.15 per 152.7 at a cost of $3.15 per square foot. Gives me a total cost of about $481.